All right, here we go. Second example here on finding an interval of convergence. I want to find the interval of convergence of this series, sigma n equals 1 to infinity of, I got an x minus 4 to the n in the top, and n times an 8 to the n. So we always set up the ratio test. L equals limit as n goes to infinity, absolute value a sub n plus 1 over a sub n. This is equal to, I get limit as n goes to infinity, absolute value, x minus 4, I'm just going to change that to an n plus 1, over n plus 1 in parentheses, times 8 to the n plus 1, divided by x minus 4 to the n, over n times 8 to the n, and absolute value. This is equal to the limit as n goes to infinity, absolute value. I'm going to copy dot flip. I get x minus 4 to the n plus 1 all over n plus 1 times 8 to the n plus 1. And I'm going to get, what do I get? N times 8 to the n when I flip over x minus 4 to the n. Again, same as in the last video, I'm going to reorder some things here. This gives me limit, although you may not have to do this. You may be able to do it without reordering them. I'm going to go ahead and do it anyway here. As n goes to infinity, absolute value, I get an x minus 4 to the n plus 1 over an x minus 4 just to the n. That is this term and this term, times, I'm going to write my 8 to the n over 8 to the n plus 1, times, what else do I have? N over n plus 1. So, very similarly to the last question, this cancels with all of those, except for, whoops, undo, not all of those except for that. This cancels with all except for that. That winds up giving me, I wanted to get my purple pen back there. That winds up being equal to the limit as n goes to infinity, absolute value. I'm left with an x minus 4 in the top. I'm left with an 8 in the bottom. And then this piece right here, the n over n plus 1, the limit as n goes to infinity, that thing's just 1. And then look, there's no more n's. So what do I get? I get x minus 4 over 8. And again, ratio test, I want that to be less than 1. So I'm going to write, I need some absolute values. So I'm going to write that again, absolute value of x minus 4 over 8 is less than 1. Remember, negative 1 less than, I'm just going to write the exact same thing except for without the absolute value, x minus 4 over 8 less than 1. What's the first step? Multiply by 8. That gives me negative 8 less than x minus 4 less than a positive 8. Now, same thing as regular algebra. I'm just going to add the 4 to all three pieces. If I add 4 here, I get negative 4 less than x, less than add 4 to 8, I get 12. So my next step is to check my endpoint. I'm going to do x equals 12 first. And then I'm going to come over here. So again, I'll zoom out. I need that original series that we were working for. I need to plug in 12 right here. If I do that, I get 12 minus 4. Let me write it. Sigma equals 1 to infinity. I'm just definitely going to get my n and my 8 to the n in the bottom. If I do 12 minus 4, well, what's that? It's 8. So this whole parentheses is going to be an 8. I'm just going to write 8 to the n. And now that cancels like that and gives me sigma n equals 1 to infinity of 1 over n. You should know that this one diverges by p series with p equal 1. Remember, anytime it's less than or equal to 1, p series will diverge. So that means that x equals 12 does not get included in the interval. So when I'm writing my answer at the end, I'm going to go x less than 12. In the previous one, that one turned into a less than or equal to, but I'm going to leave it like that in this case because I want to not include it. All right, at x equals -4. Come up here so we can see it. All right, if I'm going to get sigma equals 1 to infinity, fraction bar. Top's going to be n. Oh, sorry, bottom's going to be n times 8 to the n. The top. All right, -4. If I do a -4 minus a 4, that's a -8. Well, that is the same as talked about this in the last video. Sigma n equals 1 to infinity of -1 to the n times 8 to the n over n times 8 to the n. Again, those cancel. Sigma n equals 1 to infinity of -1 to the n over n. Now, this one, so the 12 did not converge. This one, this is the alternating series. It alternates, and then because of that, -1 to the n goes positive, negative, positive, negative. And then I just need to look at the limits as n goes to infinity of just 1 over n, which is the alternating series without the alternating piece, and that's 0. So that tells me that therefore this piece up here, this piece converges by alternating series test. So what I'm going to do in my interval right here, remember I tested both the endpoints. I'm going to write -4. For the -4, I write less than or equal to because I want to include it. So there you go. That's the interval of convergence. Hopefully you see how the previous example works and how this one works as well. I'll zoom out so you can see the whole thing. There you go. Peace.